Hello, everyone. We are soon getting started with our webinar, so grab something to drink. We will wait for other persons to join, and we are starting soon.
Also, small reminder for you guys, please remember that we have Q&A session at the end of the webinar. However, feel free to ask questions whenever you want, and we will try to answer them during the Q&A session.
Yeah, for those who just joined, hello, and you can write on chat if we are audible, if everything is okay. We would like to know that. No response so far. Still, we are waiting. Okay, we've got it. So I think we can slowly start.
In the recent years, we have witnessed an increase in the popularity of the software-defined networks, together with omnipresent automation. What is more, automation of the networks is no longer a luxury. It's now a necessity. My name is Mateusz Sługocki, and I'm DevOps engineer in CodiLime.
And my name is Radosław Kochman. I am a network engineer here at CodiLime.
Today, we will show you how to proactively approach network quality issues on post-deployment environments. The examples will be based on the SD-WAN networks, taking advantage of the fact that they are automation-friendly. By the end of this webinar, you will know how to approach automation in SD-WAN and how can you use it to increase the reliability of your infrastructure.
So today we will start from the challenges in the legacy WAN network management, and it will be followed by an SD-WAN concept overview and how it addresses those problems.
Next, we will tell you how SD-WAN fosters automation. And finally, we will garnish it with some hands-on demo.
So before we jump straight into SD-WAN related topics, we've got two personal stories for you. Back from the time when we were network engineers working on a production. So my story is, I was a network engineer working on a prod, and I had problems with fiber optic cuts because it happened quite frequently, even once a week. And after such a fiber optic cut happened, the field team needed to go there to bring up the connection again. And after that, my responsibility was to check the connectivity and routing and to make sure that everything is working as expected, as before the cutover. And I remember that it was very boring for me because that work was repetitive and it was a lot of work. And back then there were no automation for those tasks. And I was ambitious young ambitious network engineer back then, and I wanted to automate that, but due to the large and multi-vendor environment, it was pretty hard. But when I recall this story right now, it's in contrary to the SD-WAN, because in SD-WAN we've got centralized management and one vendor, which makes writing a test of end-to-end connectivity much simpler than ever, basically. So that's my story. What's yours, Mateusz?
Actually, before I start with my story, I must say that you remind me everything I struggled with when I was a NOC engineer. I will show you part of my history while I was a network specialist and I was managing data center networks for a worldwide company, which had like dozens of IPsec tunnels used to establish secure connections between their sites. It was a heck of workload to configure it and to manage it, especially when it came to adding additional tunnel or allowing next private subnet, which could flow through it. The amount of configuration was overwhelming. Like you had to remember about pre-shared keys, about access lists, about routing, about hashing methods, a lot of configuration. Now, in SD-WAN, everything is controlled out of the box. The only thing you have to worry about is to have IP connectivity between the sites. And IPsec tunnels are established automatically all together with all private routing and access lists set.
Yeah, managing a lot of IPsec tunnels was a hard job to do. I remember that. I remember that as well. So before we, those were the real life examples, but I think it's hard to understand what SD-WAN is all about without the context of the legacy one. So when I personally hear word WAN, the first thing that comes to my mind is scale. I don't only mean the physical distances between devices, but rather number of devices that we have to manage as network admins one by one, because in Legacy WAN, there is no such thing as centralized management. And what stands after the large-scale environment is complexity. Network environments tend to grow over time as we onboard new devices. So this also affects the length of the config as we establish new connections between sites, especially the IPsec ones. And as the complexity increases, so does the operational cost. And I know that me personally, as a network engineer, I'm not interested at all at this aspect, but I know that our clients and managers pay a huge amount of attention to it. So let's take a look at how SD-WAN handles those problems. So in SD-WAN, we don't care that much about scale because we've got the centralized management. And this fact alone fosters the automation. Having one vendor lowers the complexity of the network because the configs can be standardized, for example, using configuration templates. And it all sums up to the lower effort on the network engineer side, which means less cost for our managers and clients. I think it's time to take a look at the most popular SD-WAN solutions that are available on the market. So here we are. Here we have 4 examples: Cisco Catalyst SD-WAN, Palo Alto Prisma SD-WAN, VMware Velo Cloud SD-WAN, and Aruba Edge Connect SD-WAN. And of course, there are many, much more on the market as you dive deeper into the sea of the SD-WAN solutions. So I think it's worth to dive deeper into the architecture of at least 2 of them, so we will have a bigger picture of how SD-WAN is built of. Let's start with the Cisco Catalyst SD-WAN components. We've got the first one is Cisco SD-WAN Manager, which was previously called vManage. This component has a web UI that we can go to, we can log in, we see our infrastructure, we see potential problems that we can encounter in our environment. We can onboard new devices there or reconfigure existing ones.
Yeah, and also vManage is excellent example of modern use of RESTful APIs, which you can use to manage and automate network in a modern programmatic way.
Yeah, that's also important topic to highlight. Next, we've got Cisco SD-WAN Controller, which was previously called vSmart before rebranding. And I like to think about vSmarts as a brain of the SD-WAN network because they calculate the best paths among the SD-WAN components. And then we've got Cisco SD-WAN Validator, previously called vBond. This component glues together all the other components so they have connectivity and they see each other in the network. And lastly, Cisco IOS XC Catalyst SD-WAN. Those are routers that we place on-prem on our infrastructure as a hardware, or we can deploy it as a software as we want. So right now, let's take a look at the Palo Alto Prisma SD-WAN components. We've got 2 of them. Let's start with Prisma SD-WAN Controller. It also has a web UI that we can go to. We can manage our infrastructure. We can reconfigure devices there, and we can onboard new one. And also we've got Prisma SD-WAN Ion Appliance. Again, routers, hardware or software, so we can place them, for example, in the cloud if we want.
Yeah, exactly. Like you can pick whatever you need based on your needs, whether it's bare metal or virtual machine, which you can deploy in private cloud or in public cloud.
Yeah, SD-WAN solutions are real flexible when it comes to deployment. And we might get lost with all the different vendor implementation. Although SD-WAN solutions differ, the concept is still the same. SDN networks are software driven because the control plane and the management plane is deployed as a software, and that's why they are scalable and flexible. And on the other side, we've got the data plane, and we've got two options here, hardware and the software deployment. And at the end of the day, both entities are managed by a software layer. So we touched on the SD-WAN concept, but how it fosters automation. Mateusz, you can tell us more about it.
Absolutely, I will. Thank you, Radek. Now, let's talk about how SD-WAN fosters automation. First, let's look how we automate network management in the old-fashioned way. Here we have multiple routers without a central controller. And to automate management tasks, we need to write scripts that connect to each router individually. These scripts can be parameterized to handle different routers, but each script still needs to establish a connection to every single router to perform updates, configurations, and monitoring. Imagine it like sending individual emails to each team member instead of using a distribution list. While the email content might be similar and can be automated, each email still needs to be sent separately, which increases complexity and chance of errors. This approach requires managing multiple connections and sessions, which can be resource intensive and slow, especially as the number of the routers increases. It also means more complex error handling and logging, as the scripts must account for each router's unique response and potential issues. Now, let's see how we can simplify this process in SD-WAN. With SD-WAN, we introduce a centralized controller. This controller acts as the brain of our network. Instead of developing automatization that connect to each router individually, we write scripts that interact with the controller through the API, and the controller then handles all interactions with the devices. By automating through the controller, we can deploy updates, configurations, and gather monitoring data from a single point. And this centralization ensures consistency and significantly reduces the complexity of our scripts. We only need to maintain and troubleshoot the connection to the controller, not to each individual router. In summary, SD-WAN allows us to automate network management from a single place, making the process more efficient, consistent, and scalable. This is the power of SD-WAN in fostering automation. Now, let's move to frameworks and tools used for network automation. First, let's talk about each tool individually. PyTest is a popular testing framework in the Python community. It's not dedicated to network testing, but can be easily adapted for it. We can use it as a core framework for our automation. It allows us to write simple and scalable test cases, making it useful for validating network configurations and ensuring our automation scripts works as expected. NetMiko. I know most of you knows this one. So NetMiko simplifies SSH sessions management. It's built specifically for network automation. It supports a wide range of devices, helping us execute commands and retrieve outputs efficiently. pexpect is used for automating interactive applications like SSH, where we need to handle prompts and responses dynamically. For instance, if you type request update on the router and you have to confirm it, then pexpect is a great way to do it. This tool is crucial when dealing with devices that require more complex interactive sessions. TextFSM is a library for parsing semi-structured text into structured data. It's particularly useful for parsing command outputs from network devices, turning them into easily accessible data, like dictionaries, for instance. And finally, requests. Request is a simple yet elegant HTTP library for making API requests, and it's essential for interacting with RESTful APIs provided by many modern network devices and controllers. Now, let's see how we can simplify this with a comprehensive solution. Here we introduce PyTS, founded by Cisco. PyTS is dedicated to network testing. It offers robust testing capabilities, device communication, interactive automation, and data parsing, all integrated into single one framework. By using PyTS, we streamline our automation process with a unified framework that covers all aspects of network automation. This reduces the complexity of managing multiple libraries and ensures a more cohesive and maintainable code base.
I think it's worth to mention here that PyTS is only supported on the Linux-like operating systems. So if you want to use PyTS, for example, on Windows, it's a tricky thing because you need to go with the VM or you can go with the WSL2. I think it works that way.
Yeah, it does. So Windows users, don't be afraid. And on our demo, we are using Ubuntu machine to run PyTS. As we delve into the specifics of network automation, it's important to remember that efficiency is paramount. You don't need to reinvent the wheel for each automation task. Many network equipment vendors offer ready-to-use modules and SDKs that are specifically designed for their products. These modules provide pre-built function and workflows that can save your time and effort. In most cases, they are tested and supported by vendors, ensuring a smoother and more reliable automation. By leveraging those resources, you can focus on customizing your automation rather than building everything from scratch. One of such SDKs is PanoS Python from Palo Alto Networks. This SDK is designed for automating the configuration and management of their firewall products, facilitating streamlined security policy deployment and network administration. Additionally, it is well supported with comprehensive documentation and a strong community backing, making integration and troubleshooting more accessible for network administrators. Turning our attention to another powerful tool, the Cisco Catalyst 1 SDK offers a streamlined approach to automating your SD-WAN environment through vManage. This SDK simplifies the process of managing complex networks, enabling you to quickly and effectively implement changes, monitor network health, and enforce policies across your SD-WAN infrastructure. In summary, using an SDK allows us to leverage existing solutions, reduce development time, and improve overall product quality. And actually, this is what we will show you on today's demo. But before we move on, let's go through the lab topology. Our setup includes 3 sites: Site 10 in Warsaw, Site 20 in Gdańsk, and Site 30 in Krakow. Each site is connected to the internet through its own ISP edge device. In addition, we have our SD-WAN controllers, vManage, vBond, and vSmart, deployed in the public cloud, which we refer to as Site 40. This setup is not indicative of a production environment, but is constructed specifically for the purpose of this demonstration to show you the capabilities of SD-WAN automation. In the test scenario, we are going to test bidirectional forwarding detection sessions on Site 10 located in Warsaw. First, we will query vManage for the current BFD sessions of Site 10 to establish a baseline. Next, we will simulate an ISP outage by disabling the Gigabit Ethernet 2 interface on the Warsaw router. This should trigger a change in the BFD session status. We will then query vManage again to check the BFD sessions of Site 10, and at this point, we anticipate a discrepancy in the session count due to the simulated outage. And after documenting the failure, we will restore the ISP link by re-enabling the GIG2 interface and verify that BFD sessions return to their expected state. Now, let's quickly walk through the code. So let me quickly change the screen, which I'm sharing right now. All right, I think it's
Yeah, it's visible. Visual Studio Code is there.
exactly.
We can go with the code.
Exactly. So before we walk through the code, the most important thing to mention here is that we are using PyATS as our core framework. And also, we are using vendors SDK, which is Catalyst One SDK, so we could easily develop this automation. Before we walk through the test script, let me quickly explain you how PyATS works. So PyATS uses files called testbeds. And let me show you how it looks like. So testbed files contains information about the topology. Things like devices, their IP addresses, interfaces, login credentials, and so on. Everything is kept in this single testbed file. Next, we have data files. So data files are the files where we hold some custom script parameters, like site names, which we would like to test and we don't want to hardcode. And finally, we have job files. So job files define which test script we would like to execute and which data file should be used as input for those test scripts. Now, let's walk through the test script itself. Starting from the top, we have a couple of imports like Catalyst One SDK and PyATS. Also, for the sake of this presentation, I made some utils functions which can be reused in our code later on. Then we have some helper function. In our case, it's a function called are all BFDs up, and it's used among multiple subsections of our test case. So this specific function uses Catalyst One SDK, and it's querying vmanage, aka manager, through an API call. So this is the place where we are doing it. Next, we are filtering information about a specific device which we want to test, which is Warsaw device in our example. And then we are comparing if expected BFD sessions are equal to the BFD sessions which are up. And then our function returns Boolean. Next, we have common setup section where we are establishing API session with the vmanage. Then we are looking for the DUT in our testbed file based on given DUT name, which we are passing in the data file. So as you can see, in the DUT, we are passing device name called Warsaw, which is present on our testbed file. Let me quickly show it to you. So yeah, here it is, Warsaw. Moving back to the test scripts, we have get DUT from manager subsection where we are looking for specific DUT, but this time on our vmanage. And finally, we are looking for the interface for outage simulation. And we are looking for this interface based on the interface description, which we are also passing in our data file. Here it is. Moving forward, finally, we have the test case section, which is named BFD test. At the beginning of this BFD test, we are checking BFD sessions before failure by calling are all BFDs up function. Then we are simulating the outage by disabling the Gigabit Ethernet 2 interface. And we are waiting for 30 seconds so BFD sessions can go down. Next, we are checking BFD sessions with outage. And at this point, we expect that they will be down. Then we are removing outage simulation by re-enabling the Gig2 interface. And finally, we are checking for BFD session status without outage. And once again, we are calling our function are all BFDs up. And I made here 3 retries because first try can fail since BFD sessions require some time to go up. Last but not least, we have common cleanup section where we are disconnecting from our DUT to clear up the session, and we are closing session with our manager. All right, I think we can start the test case. So let me quickly type the command which will trigger it. And let's see what will happen. So PyATS takes some time to load because it's loading the testbed file, information about the test script itself.
It needs to connect to all the devices that we've specified in the common setup section. So
exactly. And as you can see here, we have logs. So first, the session with manager was established. This is API session. Next, we are looking for DUT and establishing a connection with it. And as you can see, PyATS is executing some operational and configuration commands to ensure a less error-prone automation, like no logging console. It's also checking the version to set the correct plugin. Then we are looking for the DUT on manager, and we are checking for the BFD sessions before failure. And as you can see, it is passed because the number of expected BFD sessions is equal to number of up BFD sessions. Then we are disabling the Gigabit Ethernet 2 interface by shutting it down. And we are making our countdown. It's like 30 seconds. So we are waiting for 30 seconds so BFD sessions can go down. And as you can see, number of current BFD sessions is equal to 0, which is giving us warning that connection with other devices are not established yet. Next, we are removing outer stimulation. And once again, we are waiting for 30 seconds so BFD sessions can go up.
yes, as in network realm, it's normal that we need to wait for some time after each operation, especially when the link flaps occur.
Exactly. And it is good practice to keep querying the device from time to time and not using like static sleep timers. So as you can see, BFD sessions are not up yet. So we are making another try.
But this one is shorter, right?
Yeah, this one is like 15 seconds exactly. And here you are. So after second try, number of expected sessions is equal to number of up sessions, which is giving us passed result. And now we are disconnecting with the duties and we have the test case summary. Everything is passed. So let me share with you one more thing regarding the PyATS. PyATS gives us nice functionality to walk through the logs in the browser. So it's like more user-friendly and easy to read approach. And what is very important to mention here is that PyATS offers a way to send the logs to the remote server and generate links, which you can share, for instance, with your teammates, and everyone can have like this easy to read access to the logs. Let me quickly show you how it looks. So I need to type in the console PyATS logs view. And once again, this approach is for the users which doesn't have this remote server configured. So I'm typing the PyATS logs view, and now the browser should pop up, and I already have it on my screen. However, I need to change the application which I'm sharing right now. So give me a second, guys. And I'm going to show you how it looks. I think this is the one, right?
Yeah, this one.
Yeah, this is the one. Exactly.
Got it.
So as you can see, we have a couple of runs here. And I think, yeah, this is the latest one. Let's expand this. And here you are. Everything is marked as green. We can deep dive into separate subsections to see what was going on there. So for instance, if I go to simulate outage subsection, I can see that I disabled the Gigabit Ethernet 2 interface, and then I was checking if the BFD sessions were up, and they were not. That's why we have this warning here. So yeah, this is it regarding the demo. Let me quickly go back to the presentation.
Yeah, I really like the logging capabilities and the reporting of the PyATS, because for me, even the logs present in the console after the script run are easy to read and troubleshoot, but those logs in the web browser are just great.
Yeah, absolutely. So if you have a team which is like managing your network and it's like more than one engineer, it's great for going through the logs.
Yeah. So I think it's time to sum up our webinar. What's great about the SD-WAN automation is a cohesive environment. So having one vendor and the same or very similar CLI across all of our network devices, and also centralized management. So one place that we can go to and manage our infrastructure, onboard new devices, change the configuration, do the config standardization. Those two factors makes SD-WAN architecture automation friendly.
Yeah, I must say that like if you have, let's say, devices from the single vendor, sometimes the syntax of the CLI might be different between each device, and SD-WAN standardize it.
And because of this, the development and the maintenance of the code base costs less. So I think it's time for our Q&A session. So let's take a look at the questions from you. If you have any questions for us, please ask in the proper place in the Q&A section.
Don't be shy, go ahead.
Which Python module is your favorite one for network automation?
Maybe I will answer this one. So yeah, I showed you during the webinar a couple of modules. However, my favorite one was not present on the presentation. So my favorite one is called Pydantic. And basically, it's a module where you can create data models, which are very useful for like for automation, not only network automation, but automation overall. So you can create a data models and you can use it instead of dictionaries, and which is like less error prone and contains hints. And what is also very important to mention here is that Pydantic validates the input which we are like applying to it as arguments. So let's say you have a data model which contains of a couple of integers, and normally like Python is dynamically typed language. By it means it's not verifying the type of the argument which we are passing to the, let's say, function or to the class. In Pydantic, it verifies. So by it means if you won't pass an integer and the integer is expected, you will receive validation error. So this is great, and I really recommend to use it.
Yeah, for validation, Pydantic is great because it's easy to catch differences in the outputs between even the versions of the software on the network device, because this sometimes changes from version to version. And as I think my favorite automation library is NetMiko, because that was the first library that I used in my network automation career. Let's call it that way, and it makes me feel nostalgic when I'm using NetMiko.
Yeah, the nostalgia is there.
Yeah, and also there are a lot of examples on the web how to use NetMiko, so it's really easy to just get to install and to get started to automate things with it. So really recommend it, especially for the young network automation engineers out there.
Yeah, I think like most of people who started their journey with the network automation used Paramiko or NetMiko at the first place.
Yeah, Paramiko is for more hardcore players, I would call it that way.
Yeah, exactly. Okay, I think we have more questions coming up. Let's see. Okay, can you tell me more about front end you used to view logs? So actually, like this is the thing which is generated by PyATS. It's built in. So once you install this tool and once you trigger the test case, it's automatically generated at the end of the run. The thing is here that, like I mentioned, I had to use PyATS view logs command. So the HTTP server was HTTP server started on my machine. However, in, let's say, commercial use cases, it's very good practice to configure a third-party server where the logs will be sent automatically to this HTTP server, and the link will also be generated by PyATS. So at the end of the run, you can receive the link via in the console, or through the email, or maybe on your, I don't know, maybe on your WebEx space, or maybe on your Teams or on Slack, based on the communicator which you are using in your company.
Yeah, just imagine having, for example, 100 machines that are running PyATS tests. Those are enormous amount of logs,
yeah.
And having to maintain 100 web servers, it's not a good approach. So having it centralized in some way, is a good way to go.
Yeah, and also it's good for the past. So let's say you need to store the logs for future use cases. It's good to have this remote server because everything will be kept there with some kind of backups, and it won't be like connected with the machine where you are executing the test cases. So it's good to keep it separated.
And easier to back up.
Yeah.
So we have another question. Can you recommend tools that can be used for network automation for people who are not fluent in Python? So I think it's pretty common question because a lot of network engineers are not that familiar with programming at all, I think. So my recommendation would be go with Ansible. It's a popular tool. You don't need to know how to code in Python to use Ansible, and there are a lot of modules that you can use to connect to your vendor specific devices. So there are a lot of them, and I think there are a lot of examples on the internet also how to use them. So it's pretty easy to get started with.
Yeah, absolutely. Like the community is great. So if you need any assistance, probably the answer is already there in web. So Ansible is a great example. And like Radek mentioned, most likely it's used by many people who don't know Python, but wants to automate. So Ansible is a good way to go. Or other Ansible-like tools like Chef or Puppet.
Yeah, but it depends on your specific environment because you can have, I assume that you can have devices from well-known companies and there are modules to handle those, but you can also have some, let's call it no-name network devices with no Ansible support. So it really depends.
Yeah, sometimes it's easier to use Python than Ansible in such case, but yeah, it depends on the scenario. In most cases, Ansible is a good way to go.
So that was the last question. Do you have any more questions for us?
Feel free to answer.
Yeah, you can type right now. Okay, I don't see any more questions. So we've got a new webinar announcement for you. If you want to learn about cutting-edge technologies in the networking realm, make sure to check out it. It's about utilizing Gen AI for network troubleshooting, and it will be held on September 10th by Tomasz Janaszka, our solutions architect, and of course, Adam Kłagowski, our principal network engineer.
Yeah, Tomek and Adam, they are great specialists, so for sure you will enjoy it and great knowledge will be passed by them.
And that's all from us. Thank you for joining, and please fill the survey that you can find a link on the Zoom. We will appreciate your feedback.
Exactly. Thank you very much for your attention and see you soon.
Till next time.